Welcome. In this video, we'll be finding the area of a regular polygon given the Apothem Part 2. Let's take a look at our example. Example, find the area of the regular polygon shown below. Notice that what you're provided is the actual value of the Apothem. And also, let's take a look at the number of sides. We have 1, 2, 3, 4, 5, 6. So n equals 6. And in this case, we're dealing with the regular hexagon. Also, we know that since we're dealing with the regular polygon, or a regular hexagon in this case, all 6 interior angles are congruent. Okay, so let's go ahead and figure out what are the measures of those interior angles. First, let's find the sum of interior angles in a hexagon. If you remember, we find the sum of interior angles by using the formula 180 times n minus 2, where n is the number of sides. So in this case, we have 180 times 6 minus 2, which simplifies into 180 times 4, which is simply 720 degrees. So that's the sum of interior angles. But since we are dealing with a regular hexagon, we know that we have 6 congruent interior angles. We can figure out the measure of one interior angle. So one interior angle measures simply 720 degrees divided by the number of angles, which in this case is 6. And we can say, well, 720 divided by 6, it's simply 120 degrees. So each one of these particular angles measures 120 degrees. Now, what we're going to do is simply reflect this apothem over here, and we're going to trace a triangle here, okay? Now, notice that this is going to be perpendicular. This segment is perpendicular to the base, and we know that this particular side length is 4 square root of 3. So let's go ahead and extract it over here so we can appreciate it better. So we have that little triangle. I'm going to say that this base of this special triangle is simply x. So I'm going to call this x. I know that this is the apothem, so that's 4 square root of 3. We also know that this is a 90-degree angle. And since we're taking the 120 degrees angle here, and we're going to bisect it to get this radius from the vertex to the apothem, we know that we're going to split that into 2 parts. So we have 120 divided by 2 gives us 60. So notice this is 60, this is 90. Since the sum of interior angles in a triangle is 180, we know that this is equal to 30 degrees. Now, we're dealing with the special right triangle. So since this side, the one across from the 30-degree angle is x, we know that the long leg, or the side across from your 60-degree angle, is equal to x square root of 3. And we know that the hypotenuse, or the actual side across from your 90-degree angle, is always 2x, since we're dealing with the special right triangles. Okay, look at this. By matching, we know that x is equal to 4. And then we can actually say, well, then the hypotenuse here, or the radius, is equal to 2 times x, or 2 times 4, which is 8. Well, what we want to focus on is this particular triangle here. We have the base, which is x, and we also have the actual apothem here. Well, what does that mean? That means then that the entire base of the hexagon is equal to 2x's. So one side length of the hexagon, or the base, is equal to 2x's. But we know that each x is 4, so we can say that that's just 2 times 4, which is 8. Now we can figure out the perimeter. The perimeter is equal to, in this case, the number of sides times the side length. So we can say the number of sides is 6, the side length is 8. So we have 6 times 8 is equal to 48 units. That's how much the perimeter is. Now, to figure out the area, we're going to just multiply 1/2 times perimeter times the apothem. And in this case, we're going to have 1/2 times the perimeter, which is 48 units, times the apothem, which is 4 times the square root of 3 units. Now, notice that we can say, well, this is equal to half of 48, which is 24 units, times 4 square root of 3 units. So let's multiply the 24 by the 4, and we get that that's simply 96 times the square root of 3 times units, which becomes unit squared. So we can say, therefore, the area of the hexagon, in this case, this regular hexagon, is equal to 96 square root of 3 square units. And that's how we can find the area of a regular polygon given the apothem. Thank you for watching and have a wonderful day.